Okay, good afternoon, everybody.
Hmm.
Good afternoon, sir. Good afternoon, ma'am.
Yeah, good
And
afternoon, Tushar.
everyone participants, very good afternoon to you. And very warm welcome from Entrepreneurship Cell of Guru Nanak Khalsa College. On behalf of Dr. Pratiksha, ma'am, the head of Entrepreneurship Cell, I would like to introduce our today's speaker, Mr. Akshat Kadam. So he is the CEO of Devlearn Technologies, and it's my very pleasure to introduce him to among you. So he has done his MTech in electrical engineering from IIT Bombay and specialization in signal processing. He has also experience of working with Sony Corporation for about 4+ years and a research scientist in volumetric imaging department. He has worked upon introducing motion parallax in multi-stack domain projects by omnidirectional department video and also worked on a real-time pre-video system for commercial broadcasting product showcase. Also, we have with us Dr. Vidya Kadam ma'am. Dr. Vidya Kadam ma'am is also managing director of Devlan Technologies, and she has over 20 years of experience in.
Okay, thanks for the introduction, Tushar. I hope my screen is visible to everybody. I'd just like to confirm that before we get started.
Yes, sir. It is visible.
Okay, thank you very much. All right, I'll proceed then. And if there are any technical inconsistencies you may notice in the stream, please let me know. I will make adjustments while we go. Okay. So, first of all, very good afternoon to everybody, and I hope everyone's safe at home and like laid back, and hope we can just have a nice afternoon session over here. Okay. So, welcome to an introduction to Python and data science and business intelligence. So, I will talk a little bit about what This session is originally intended to be an orientation for an oncoming batch initiative that we have tied up with JN Khalsa College for. And all the students that are currently viewing and attending, I would first like to give you just a brief about what these technologies are about and how learning these specific programming languages and technologies will help you in your careers and in your studies as well. So, although this talk was titled a little bit more specific to Python in data science, but I have switched it a little bit when I noticed that most of our attendees here are students, like a whooping more than 95%. So let me first share with you a quick agenda. But before we start, this is a quick introduction of myself. I'm sure Tushar has already covered the points, but basically, my name is Akshat Kadam, and I head technology and academic initiatives at Develop. So, yeah, it's a pleasure to interact with everybody, and yeah, okay, let's get started then. All right. So this is the agenda for all the points that I want to touch upon today in our talk, and I have mostly chosen these points because what we have noticed in our time so far is that most students are still the awareness levels are still fairly low about the origins and the main concepts of data science and what is the changing trends that we're seeing in the industry and why these technologies are important. So I'd first like to go the other way around and give you a brief about what data science is and how it stems from how it helps with AI and how big data plays a huge role over here. And finally, we'll examine a little bit more closely about what exactly these data scientists and analysts do in their jobs. There is also an additional term for data engineering. And what is exactly business intelligence and how it fits in this entire big picture. And finally, coming to the crux of the point that I'd like to make today is why Python has become such a popular programming language today and what has led to its rise in popularity, and how it has become a common thread in all of the data science analysis workflows that we're seeing today actually in the industry. Okay. So let's get started. I'll touch upon each of these major points as we start exploring them. Okay. So I'll start with before we actually get started with any main points. What I want to put contextualize for everybody is that the reason that India today is still lagging behind as compared to the rest of the world in terms of employability and even competency in these fields, despite having such a high number of graduates, such a huge talent pool, is that there is a little bit less awareness, and somehow students and even fresh graduates are finding themselves unprepared for an industry that is changing extremely fast. And what is happening is because technologies that companies are adopting are changing so fast, their requirements of their employees are also changing accordingly, and people are not able to keep up with these skill sets, these requirements. And what our role as Devilon Technologies here is that we want to ally with higher education institutions and institutes that cater to so many, the next generation of graduates. And we want to catch you up and keep you up with these technologies so that you will find yourself relevant when you enter the job market, and you'll be able to actually become self-reliant in this very, very changing world, especially a world that has changed so much in just the last year. Okay. So let's just start with a small history lesson. I want to touch upon how this data science field actually came to be, and how it has evolved to this point today. So first of all, I'll touch a little bit about what artificial intelligence is later. But if any student here is familiar with the term data mining, I think it's sufficient to say that this is something that started in the late 90s after the internet boom started. And this was coined by a few scientists, of course, in academia, who were trying to use statistical methods to obtain inferences from data. Now, this seems like a very basic concept, but it was extremely revolutionary at the time. And what happened is, from that point onwards, right until the mid 2000s, is that there were certain scientists who came up with the idea that we should combine data mining and computer science. And that's how we actually came, the term, or the field of data science was conceived. So basically what they kind of did is that they made statistics and they made it extremely technical, and they kind of added a whole computational flavor to it. Okay, so this is how data science actually came about. But what actually accelerated this field is that is with the advent, or you would say the evolution of the internet or the web from 1.0 to 2.0. Now this was actually a big monumental leap, and it created a paradigm shift in the way data is generated in across economic activity. And that is actually the fuel. It created the fuel for what we call data science research, or you could say artificial intelligence, including machine learning or even deep learning applications. So I'll talk about those terms a little bit ahead. Now, and also elaborate on Web 2.0 shortly. All right. So another thing that I want to touch upon is, while data science and big data was developing up to this point in 2012, our traditional concepts or conceived notions of artificial intelligence or AI were extremely primitive, and they were also more of towards the line that people were convinced that AI as a technology is infeasible, and it will not lead to anything big. But there was a big a milestone change that happened in 2012. Now, this came about with a landmark research paper by Professor Geoffrey Hinton of University of Toronto. And what he did was a very interesting experiment when he leveraged big data with our old methods of artificial intelligence. And what he found is that the combination of these two leads to something very exceptional. And what that led to is a complete revolution from that point onwards. So, right from 2012 to the current date, you see AI research has exploded across all fields of study, and data science has now come to the complete forefront, the spotlight for across not just academia but also industry and science technology wherever you look. So that's how even the word data science, the term, the field, it kind of came to the forefront, where people started taking notice that okay, this is something that we have to be more cognizant about, more aware about. And finally, we come here today when we see that data analytics, science, and engineering are some of the most popular and future-proof jobs today, because there are so many speculations that people make that with the increase of automation, jobs are in danger, and there is a lot of speculation in the market. But there is one thing that everybody agrees with, is that these sort of job roles that involve actually dealing with big data and analyzing it and also applying scientific and engineering methods to it is a job field that is going to be at the center of most economic activity in the future. Okay, so I hope that this was a bit of a good introduction and a bit of a small timeline about how this field of data science actually developed. So let me just transition a little bit to what you should think about when you think about artificial intelligence. Now, I'm sure many students today might have at least heard the term machine learning or deep learning in some context, and if not, you would have definitely heard AI, at least in your newspaper or some article somewhere, because everybody's talking about it. It's extremely hip or in culture and popular media. Now, there is something that not everybody touches upon in popular media, is that how these three things relate. So, one thing that I want to at least make clear to all our viewers today is that at least when you go back from this talk, I want you to have a good notion of what how these technologies relate to each other. So let me just say for now that AI is a general term. It covers all conceivable types of intelligence. So it is, in its more purest theoretical form, artificial intelligence. So although we cover the space of human intelligence, there can be intelligence that is very different from us, a kind of intelligence even we will not conceive about. But that would make this talk extremely philosophical and metaphysical. So I'm not going to touch upon that, and that is not what even we mostly as society are concerned with today. What we are concerned with is to actually expand upon and explore all forms of human intelligence that we have tried to replicate in machines today. So, and that is what machine learning is. That is basically, machine learning is it's a field of study. It's full of, at its core, it's mathematics and statistics. And it studies how computer logic, or so machines, so to say, their algorithms or, their methods, their processing can improve, or with the use of data mining and, statistical techniques. So the same methods that machines would use till now, we change the method a bit and we give it a lot of real world data. And we see how the same ability of the machine to decide certain things, to predict, how that improves. So that is entirely the field of machine learning. And finally, just to give you a small teaser about what deep learning is, deep learning is, in essence, completely falls within machine learning. It is an entire subset of it, and it's basically a new type of machine learning that leverages massive amounts of data. So similar to that 2012 research I mentioned earlier, and it uses new techniques, especially parallel computing and so many things that have evolved in the last decade, especially the concept of neural networks to surpass even humans in performance in various fields. So let me just name two fields that probably you might be aware about. So this is something that is not recent. It is about, I'd say, at least 5 years old, where the world champion at this, not so popular in India, but at least popular in the rest of the world, it's called Go. It is a many times more complex game than chess, and Google was able to create an AI that could beat this world champion at this game. So this is the first example of how we see that AI or machines can actually defeat humans at something. And that was, although it was about 5 6 years ago, what happened is in just 3 more years, we have AI that is defeating humans in much more complex tasks. So this is, I think some students might be aware of what this game is. It's called Dota, and it has a very big cult following. There are world championships for this with huge cash prizes all over the world. And it's an extremely complex game with an entire gamut of characters and moves and skill sets. And they were able to design AI to completely defeat even world champions at this game. So we are seeing, and this is all possible through methods such as deep learning. So this is just a bit of a teaser as to what the capabilities of AI can be. So let's move on a bit. And I want to first talk about what exactly is big data. Now, people hear the term big data and they use it as misnomers. They use it a little bit incorrectly very often. I want to talk about how big data started and also to give you more insight and background as to why big data is relevant today to us. Okay, so I'm sure most students right now in college today, they will probably not be aware of websites such as this, of this format. So these are Web 1.0 websites. This is MSN.com. There were similar websites called Yahoo, Bing, earlier versions of Bing, and also Netscape, those browsers. So that was the state of the internet back then. That was more like a digital encyclopedia. And consumers of the internet were just seeing information and that's it. They were not sending back much information. But what happened is that with the evolution of 1.0 to 2.0, although you don't need to understand what's happening inside them, what you at least need to get is that the internet became much more interactive and much more driven by the users and not just the original content publishers. Now, with apps such as Facebook, Twitter, social media websites, where you interact with things every day, we have people that are expressing opinions, interacting with things, and leaving behind a digital footprint about what a person is doing on the internet every day. Now, this is happening at a worldwide scale, and this is generating a lot more data than what we originally did. So, the scale at which data was generated was completely blew up when the internet evolved, and that is why we today have big data. So, let me just give you a little bit more about what this big data is actually doing. What is possible with it is that because data has evolved so much across all sectors of economic activity, people's data can now be used across all aspects of a person's life, right from healthcare, travel, education, even communications, of course, because mobile numbers were the original piece of personal information that a person had before Web 2.0. And of course, I don't have to tell you how Amazon and Netflix are completely using your own data to predict and recommend you what is the next thing that you might want to buy or what might want to watch online. Okay, so this is what is possible with big data. And let me also give you like a few applications about what people can usually do with it. Is that say for example, you have even say a Google search or a passport scan, your online shopping history. All of these can be collected, aggregated, and monetized. So by monetizing, we see is that the ad market today is completely driven by data, and that is of course also sometimes why you see certain companies that are coming in the news for certain say high profile scams or certain issues where where companies are selling data that users have not given permission to, and that is creating a whole new type of problems today that people never even conceived about. And the law doesn't even exist for these issues because they were just never a problem before. Now, let me also just say that because data is exploding so fast, and what people are also trying to do today is that they're trying to make algorithms and they're trying to increase computing capacity that will keep up with this sort of data processing every year, because not only are we churning more data every year, we're also increasing the rate of processing of this data year on year. And this is only possible through hardware and software innovation. And of course, software innovation will keep happening, but hardware innovation is going to drive a lot of this in the future. A small heuristic I wanted to place in front of you is that they often said in 2015 that our smartphones back then had reached the point that one smartphone had more computing capacity than all of NASA, when whatever they used in the 1969 moon landing mission, and that is just inside your pocket. Today is 2021, and they say in just a little bit more time, one smartphone might have enough raw computing power to overcome that of an entire human brain. And within just about another 10 to 15 years, we might see that the same device could be scaled up to cover all of humanity. So that is completely mind-boggling, and it's hard to even conceive what that means. But if there's anything you pick up from this, it's that processing these large amounts of data, distributed computing, all of these concepts are only going to become more important from here on out. Okay, so that was the first section on what is AI, what is big data, how these two things are playing together. I'd just like to take a quick break and see if there are any questions from say the live chat or from anybody in the meet. Tushar, can you just correspond on that?
Yes, sir.
Yeah. So if anybody has any questions in the currently who are in the meeting, I'd be happy to probably field a few, and we can maybe field chat questions in the end. All right. Let's proceed in that way. Okay, so let me just give you a very, very small teaser. This is a small section. I just want to talk about how jobs are changing in the industry and what is this evolving nature of jobs. So the first, I think it's important to pull a few statistics here. And what you will probably see over here is that these job roles over the past 10 years, ever since, and this is very well in line with the timeline that I have explained so far. Now, what we're seeing on job markets, on recruiting websites, everywhere in statistics is that jobs with keywords like data analyst, scientist, data scientist, or even data engineering, these sorts of keywords and nomenclatures are becoming more and more popular, more relevant out there in the market now. So often, if you looked at the same recruiting websites, you look at Indeed, you look at Naukri.com, probably 5 years ago you would not find all these many job descriptions like this. But today it's completely different, and that is completely in line with the need for corporations to use all of this data that they're generating to solve their problems, to create new products for them, and to create more efficient products for them. So I will touch upon what exactly these data scientists and analysts do a little bit ahead. But I think something that you should be it's a big takeaway for everybody watching today is that this is one of the few fields where candidates with less than 5%, 5 years of experience are covering 3/4 of the job market. Now, this is mind-boggling, because if you were to look at, say, programming in traditional languages like, say, Java or C++, the fraction of freshers or people with less than 5 years experience is much lesser among everybody who are commanding jobs today in the market. Now, a big part of this is that this field itself is less than 5 to 10 years old. So it is only natural that most professionals that are right now in the market don't have much experience already. So I would say this is a very, very good time to get into this field and to at least start exploring what your options are. There is no one fixed track. There is an entire pyramid of ranges of tasks that you can explore, careers that you can explore ahead. So I'll get on that. I'll talk more about that pyramid a little bit ahead. And the final point I want to raise over here is that these are some of the programming languages that are becoming extremely popular for these job roles. And what you will notice here is that Python currently stands at number 2. Although this is a statistic from 2007, I think a more recent statistic placed it extremely close to number 1. And Python and R are absolutely the top 2 languages of choice for anybody even trying to have a foundation in this field, like in this entire range of job roles. Okay, so let me talk about a little bit more about what these jobs are like. So I'm talking about these analyst jobs and the data scientist jobs, but what exactly are companies looking for in these jobs? So there is a very common saying, at least within the community of current industry experts, wherein any data analyst or scientist, when he's working on the field, on the ground, he basically has 4 quadrants of responsibility or 4 skill sets that everybody is judged upon. And those are namely analytics, specific domain knowledge, that is depending on what sort of field he's working in, programming, of course, because he has to implement everything that he's trying to analyze, and finally communication, because a person doesn't work alone in a vacuum. If you are an analyst for a company, you have the responsibility to communicate your findings to management, because finally the key of analytics and data science jobs is that they are giving people the power to decide what will happen in the future and what is the best thing that I need to do today so that my product, my company is going to do better in the future. And that is why if today you are an analyst that has the ability to analyze your company's data, to create predictions, then you should also be able to communicate them. And these are some of I've just picked out 2 very popular companies that are hiring tremendously in large quantities. And of course, I don't need to tell you about Amazon, but this is a very template job description that you will find if you look at Amazon's job listings. And this is extremely well in line with the 4 pillars of what a data scientist needs to have in his job, in his skill set, which is analytics, communication, domain knowledge. So for example, if you're working in a ad agency, so you should know what are the sort of ads that your agency is doing. Say if you're working at, say for example, Amazon, you need to know what e-commerce is about, how Amazon works, what is the Amazon platform about, and that is how you will actually be able to create an insight for the company that it will help it do better than what it is already doing today. Okay, so of course this domain knowledge changes everywhere, but the basic skills, that is within analytics and programming, these are something that everybody has to develop in every foundation. All right, so that was a little bit about how these job roles are changing, and how industries are kind of switching up the kind of candidates they're looking for, more popular. And I think everybody might have seen that there is so much, the word data science, data analytics, data engineer, I've thrown that around a lot. Now, let's also take a little bit of a deeper look at what exactly would a person do at these jobs, or what is expected of you at this job, and how you would perceive this entire field of study to be. All right, so let me be extremely clear. Data science is not about creating complicated models to possibly show very flashy trends or using extremely complex technologies. Data science is about answering questions, basic questions for the company you're working for, and helping them improve their business. So, and the questions that you ask, the questions that are asked inside the company, wherever you work, I would like everybody who is listening today to just do a little bit of a thought experiment and put themselves in the shoes that, say, they are a data analyst at a company, and they are working with seniors, with management, with project leaders, and the company has a product, the company has a service, and they are generating data from that service. It could be any service. It could be, I could have a small tailor business, and I could be managing clients online through a sort of an online e-shop, and my e-shop could be generating data for me every day, a lot, and I am a simple analyst at this company. Now, the work that I will do will depend upon the sort of questions that are being asked within my current workplace. So for example, and this could be all sorts of questions, but mostly there are three main types that we talk about. So of course, one is predictive, when people are more interested in what happens in the what is going to happen, and how can we maximize our profit or our sales in the coming times. So what should we do for that? So that is how you would do predictive analysis. And for example, prescriptive analysis would talk about what is the current state of the business or the product. And I could be looking at data, and your boss could be questioning you as, why is this happening? Why are so many people logging in but not clicking on the buy button? What will happen if this sort of trend continues? So that is how you could come up with prescriptive charts. And finally, descriptive talks about goes more into the details as to what is actually the reasons for why some things are happening. And I think that mostly these three verticals or these pillars would very well encompass what are all the questions that you would sort of encounter within this entire field. And believe it or not, for all the flashy, all the sophisticated job descriptions that you see in the market, finally when you're at the job, these are the questions you are getting. So you are getting extremely simple questions. Why is this happening? So we have this product, can you take a look at this, see how we can improve? This is the sort of work that you would do as a data analyst or a scientist. All right. So the next thing I'd like to touch upon is something that is not often talked about in popular media for sure, and even amongst industry experts. For some reason, they don't touch a lot upon about this, because possibly because of its complexity or anything. But I think this chart, this right here, this pyramid should be your biggest takeaway in this little small orientation here today, and that is what exactly happens within this entire pyramid of data science. And what are the sort of things that you would do, and what is the most important thing? So as any pyramid structure goes, the base is the most important. Without the base, nothing above it will stand. And that is the most mundane and basic thing of data collection. So very basic things like obtaining data, acquisition of data. So if I am an ad agency, if I'm a marketing agency, how would I get data of my prospective candidates? So acquiring that data, that is collection. Now you could do it to your existing products. Simple, it's a very mundane engineering task. And from there you actually start into venturing into the fields that data engineers work on. So that's where you talk about data pipelining, or storing, cataloging information. So much of the data, around over 80 to 90% of data that is currently out there in the world, is unstructured. And if we take that data as is, you cannot do anything useful with it. What you do need to do is process it a bit, align it, normalize it. I would like everybody to think of this process very similar to analogous to cooking. You cannot use raw materials as they are. You have to do a little bit of preparation work. You probably have to marinate certain things, chop, cut, dice. So I think that is how you should also perceive this entire pipeline and this pyramid. And you would venture up from basic software tasks to data engineering. And here is where this is the area where you would the crux of any analyst lies, where and this is, I would also like to mention, is where most companies today are. Apart from the extremely advanced tech giants who are constantly innovating and creating products that are extremely new and pushing the state of the art. Usually, yes, a lot of their work happens over here, but for most companies, for you, if you're listening today, what will likely happen is that companies are looking for a person who will do this work. So simple analytics, simple feature training, very, very basic pattern recognition. So, that is where the core of most insights come from. Business insights come from here, and this is where the blanket term of business intelligence also comes from. So, a business intelligence agent is somebody who has the skills to do this analysis and then move on to, and also has the communication skills to push it to marketing staff, to push it to clients, to push it to higher management. So, if you're think of yourself as a businessman, a person who's growing a business, but also knows how to grow it. So that is where the intelligence of the intelligence of artificial intelligence mixed with business. That is how you should think about business intelligence. And finally, you can step up your analytics by creating hypotheses. This is where you start venturing into the field of science, where you have an assumption of how things are when you don't really know, and then test over that assumption. And finally, you realize that, okay, my guess was correct or my guess was wrong. If it was wrong, I'll change something, I'll explore more. If it is correct, I have something that was not known before. And this is value, because when a company knows something that other companies don't know, that is how the company has the ability to go ahead of the competition. So this is why this pyramid of how you should perceive this entire field comes into picture. So if you do not know how to do basic pattern recognition or feature analysis, you shouldn't know, or you shouldn't be studying deep learning or probably natural language processing, all those high funda terms that are thrown around in the market, because that is exactly like, if you have a dish and you are putting seasoning on it, you're putting kesar on it, but you have not put salt, you have not put pepper, the basics are not there. So, which is why I would like everybody to completely, absorb this chart, and this should be a biggest takeaway today. All right. So, I think when you talk about data scientists, or the sort of job descriptions that you have out there in the market, they also differ a lot. Sometimes, many students or many people, professionals, they kind of tell me that, hey, I was looking at data scientist job descriptions on the internet. I was searching around, and I found that these job descriptions, they keep changing so much. I mean, they are very different. They're not all very similar. Some look very, very constrained, or extremely narrow, but some are extremely broad. There are some jobs that talk about this entire space of things, and some that just talk about one of them. So to answer that question, I'd just like to say that the size of the company that you're probably going to work at, that has a big role to play in what is the sort of work that you're expected to do at what label. So let me just to give you a little bit of heuristic. So if you're a small to medium sized firm, basic data collection, that is the domain of any basic engineer, software engineer, whoever made the platform or whoever is collecting data on the field. This is their domain. And if you actually want to work with storing, cataloging, retrieving this data, that's the field of data engineers. And finally, the analysis, or the actual process of coming up with inferences of that data, that is the whole scientist or analyst role. So usually this term is used interchangeably between companies, but that is probably most likely because the companies themselves are not too sure about what they want, and they just want somebody who will solve their problems. So as a student, as an applicant, if you do get the job, your first priority should be to understand the business of the company, and you give them what they need. You sense what they need, and then you give it to them. So that is how companies are trying to keep up with this entire changing landscape, because if you're doing something you have never done before, you probably would falter a little bit. So that is also what we're seeing with so many companies today. So when we have so many various and mixed up job descriptions. So, but what you will see in big corporations, companies that know what they're doing, they are probably a lot more structured and systematic with how they get candidates, how they train them, how they use them. So roles are extremely well defined. But again, without any doubt, as an analyst, this is your main the crux of what you will be doing, and this is where most value is generated today uh, in the market. All right. So I'll just give a very small point about how AI and deep learning features into this with these big corporations. Is that uh, what they look for is that because these corporations are extremely right, they do know exactly what sort of research they're trying to do, and what are exactly the sort of algorithms, the sort of domain specific knowledge they require. So these roles fall more under, you would finally find these roles as, core machine learning or, core research into certain domains. So that's why they probably look for people with a master's or ahead. But nevertheless, these roles are completely open to anybody who has the skills to, fulfill the requirements. So I think this everybody can, just try to take a good look at this and probably even study it up a little bit more in your free time. Okay. So finally, again, the last thing that I want to touch upon today is how Python fits in with this entire, big picture, and like how it's connected to this entire workflow in the world, why it's relevant to everybody today, and why it's going to continue to grow even further today. Okay, so Tushar, can I just check in once more to see if anybody has any further questions?
Yes, sir. There are few questions, and I am posting it in our chat, this Google Meet chat. You can see it from here.
All right. So, okay, if that's the case, then let's just tackle these in the end. I think we're mostly in the towards the final sections of the talk. So we may finish in another 10-15 minutes, depending on how much time we have left. Let's tackle questions.
Sure, sir.
Okay, right. All right. So coming to Python and its popularity. Now, this is something that I found extremely interesting. And as somebody who has certain development experience and someone who has interacted with a lot of developers, uh, to me, the most important indicator of any programming language's popularity is how that programming language does on Stack Overflow and other debugging forums. So if you have done any sort of professional programming, you will soon come to know that as a programmer, you usually don't remember the syntax of your programming language all the time. I have done certain, say for example, let me take a very simple example. If I have to open a certain type of file in Python, I have probably done it so many times. I've done it 10, 15, 20 times, in the last 1-2 years. But even today, if I start doing it, I will just scratch my head a little bit and wonder, how do you do this one little bit again? I know how you do it, but I don't remember the exact command. And that's when I go to Stack Overflow. I quickly Google how to do this in Python. So that's usually the most common thing any developer does. And a developer that says that he doesn't use Stack Overflow is probably lying, and or he's not a very good developer. So these are statistics that Stack Overflow has brought about how Python and questions about Python have grown in the last just 6 years, from 12 to 18, and taking extrapolating these to 2020, this has now become the number one programming language for which questions are asked. And although this is a growth rate, and maybe the total questions for Java or JavaScript are a little bit higher, but Python is growing at an exceptional rate. And I will talk about just to give you a few short reasons as to why. But this is unlike anything we have ever seen before. So no language till now has become this popular and this widely used ever So this is the first instance of a widely dominated programming language you've seen. Because, and this is, you should just see these statistics as, you know, a conservative benchmark, because Python is used so much, not just technical people, not just engineers, accountants, even statisticians are using this. There are certain instances of people in the arts field who are using Python for some visualization purpose, some basic work, and that is the beauty of it. So let me just touch upon what are the various types of people that are actually using it today. So Python is, without a question, the world's fastest growing programming language, and you know, it is extremely popular, especially in the young crowd. You know, those who are freshers in the industry, those who are just growing now, and of course, without question, software engineers use it. But so do mathematicians. You know, for basic calculation work, for simulations, data analysts, with of course, it goes without saying, scientists use it too, you know, for basic simulations. And this would probably surprise some people, but accountants and even network engineers are now able to use Python, because Python is making everybody's life easy on the job. And I think I don't need to explain that Python has now become an extremely popular language even for kids. We have kids in 8th standard, 9th standard who are starting to study Python, and they are able to create very, very small scale but still innovative and interesting projects in the, and because it is sparking creativity, it has become so, that's how its popularity has grown. And if there is something that I should mention is that, you know, the natural question that comes, you know, pops up is why? Like, why is everybody using it? So, why does an accountant who doesn't normally know programming, why is he able to use or is preferring Python over some other tool? So, the simplest answer for that is of its high level syntax. Now, probably somebody might, you know, people might wonder, what is high level? Does it mean high funda, like high sophisticated? No, high level actually means extremely simple, easy to understand. So to give you a sort of a visual, the closer you are to hardware, to actual memory management, the closer you are to actually working with binary digits, with bits of ones and zero, that is low level. So low level, say for example, assembly programming would be low level. A little bit above that would be C programming, where, you know, you directly deal with addresses or memory on your computer, and you're probably manipulating the memory addresses on your computer. So that's where C programming becomes, you know, complicated, because everybody hates pointers. Nobody wants to the hassle of dealing with them. But with Python, you do not have to worry about those things. It just takes care of everything. And that's why, you know, even commerce students, art students, they find that it is the closest thing you will find in programming that is similar to writing in English, in just plain English. So, and that is why it has become so popular. And even kids are able to do it because of that. Okay, so there are four, you know, main reasons that describe why, you know, this entire thing is, Python is so useful across everything. So and of course, like, I'll just touch a little bit about each of them. Is that it is extremely cross-platform, and what that means is that people who are learning this language today, can they work with people who have not learned this language yet but have been working for a long time? Say you are working on, you know, you've only programmed Python for Windows till now. Tomorrow you go to a company that uses Linux, that where they work on Mac. You would probably be in trouble if you were working with C or C++. But with Python, you won't even feel the difference when you change platforms into, you know, when operating systems change completely. And there's a large number of libraries. And the best part is that Python can interface extremely well with languages like C++, Java, traditional languages, you know, more medium to low level languages that are useful for writing professional grade software. So tomorrow, if you go to a company as even a software engineer or a tester, and you find that all the developers are working with C, C++, Java, and you're working with Python, you can still work with them, because Python can interface with these languages well. So it's definitely the most simple and eyes closed the best choice to make. And of course, after that, high level, huge community. Like I mentioned, if you have any problems, you go to Stack Overflow. You probably it'll be easier to find the solution to an answer in Python than it would be in some other young language like Ruby or Scala or uh, any of the budding languages that are out there. All right. So I think we're close to the final point that I'd like to make is that since we were talking so much about data science and business intelligence, it is worth mentioning that Python and R programming, along with it, are the foundation where all of these engineering, science, analytics, and even the specific domain research rests upon. So, with the basic tool set of programming and the ability to quickly script something, is you will be able to jump into an engineering role where, say, if you want to work with Hadoop or you want to work with Spark, anything related to data pipelining or that sort of gritty work, or you want to move into analytics, little bit more glamorous work of working actually on business problems. Again, you will be using Python for that. And finally, if you are doing even the top, or the pinnacle, the spearhead of work, say in any sort of research, you want to work with neural networks, you want to work with deep learning, you want to use it in all these applications such as AR, VR, or even domain specific work like say machine vision or sort of bioinformatics for that matter. Python again is going to be the language you're going to program in, because all of these platforms, they do use Python inside it. All right. So I think that covers most of the points I wanted to raise today. And just one last thing I wanted to state is that, again, this little talk over here is just an orientation as to why you should sign up for this course that we are very soon starting with Khalsa College. And it's a completely foundational course. If you have zero programming experience, you can join. You will be able to catch up, and we will be starting from absolute zero basics, with the assumption that you have never written any line of code, and it's just that easy. And finally, of course, it's online. It's going to be very well paced. You will not be everyone. I think your exams are over. You're a little bit trying to de-stress. So this is going to be a very lightweight class. You will have hands-on experience in writing code, wherein if you are seeing something that the teacher or the presenter is talking about, and at the same time you will be able to write it down. You can probably even do it on your mobile phone. We have the tools for that. And I think the best part about this is that this is completely sponsored by our collaboration with RUSA, so it's entirely free of charge. I will strongly recommend that everybody signs up to the course, and I'm sure the coordinators will be sharing a small registration link with everybody. So yeah, just to fill that up. Okay, right. So that's it for the talk today. I think we're doing just perfectly well in time. We just have a little bit of time to answer a few questions. Okay.